Assalamu alaikum and good evening to all. Water chemistry live class with Jakir from Dhaka, Bangladesh. As per our time schedule, we are near about 10:30, so I'm waiting to connect you all and welcome you all again on our 13th day of class. Thank you, Nusrat, for joining. You'd like to connect, thank you. I don't know whether your internet over there is okay or not, so I'm waiting for connecting more people. And I will talk today on cycle of concentration and its importance and its implication in cooling water treatment or boiler water treatment or RO system, or even in any water body where how cycle of concentration impact. So please, if you join already, share with your page and watch party and your team and loved one. I'm waiting to connect more people, and also I like to run a song or a music for you all, so that by the time we can hear the music. And I like to keep reverse my camera, and I like to share a song that you all can enjoy. And this is a very critical time. Many people need support, so we all have to be safe, and we all have to be extend our hands to other people to connect. So let's enjoy a song and waiting for connecting more people.
মানুষ মানুষের জন্যে জীবন জীবনের জন্যে একটু সহানুভূতি
Please connect and share with your wall and team and group. I also share in my wall.
পেতে পারে না বন্ধু মানুষ মানুষের জন্যে জীবন জীবনের জন্যে একটু সহানুভূতি কি মানুষ পেতে পারে না বন্ধু মানুষ মানুষের জন্যে।
I'm waiting to connect you all. Please, if you connected, share with your wall and connect your team, tag your team, so that when the people number will high, I will start the main topics. Thank you.
মানুষ মানুষকে পণ্য করে, মানুষ মানুষকে জীবিকা করে, মানুষ মানুষকে পণ্য করে, মানুষ মানুষকে জীবিকা করে। পুরনো ইতিহাস ফিরে এলে লজ্জা কি তুমি পাবে না ও বন্ধু মানুষ মানুষের জন্যে জীবন জীবনের জন্যে একটু সহানুভূতি কি মানুষ পেতে পারে না।
Thank you for connecting. Thank you. Please share with your team. Thank you for connecting me. Share with your team.
বলো কি তোমার ক্ষতি জীবনের অথই নদী আর হয় তোমাকে ভয়ে দুর্বল মানুষ যদি। বলো কি তোমার ক্ষতি জীবনের অথই নদী আর হয় তোমাকে ভয়ে দুর্বল মানুষ যদি। মানুষ যদি সে না হয় মানুষ মানব কখনো হয় না মানুষ। মানুষ যদি সে না হয় মানুষ মানব কখনো হয় না মানুষ। যদি মানব কখনো বা হয় মানুষ লজ্জা কি তুমি পাবে না ও বন্ধু মানুষ মানুষের জন্যে জীবন জীবনের জন্যে একটু সহানুভূতি কি মানুষ পেতে পারে না ও বন্ধু মানুষ মানুষের জন্যে।
Thank you very much. Thank you for connecting. Many of you, I think, helping different kind of people and this is the right time to help others, and because many people need your help. So that's why I like this song very much. I welcome you everybody, and those you already connected, please share with your world, share with your team, so that they can have the knowledge they can have, and they can also enjoy the class. So today I am waiting to your comments that you should give me a topic that we can discuss. So very few question come. So even after yesterday discussion, I found very good lot of question come. So if you have any more question today, you can ask me. I keep a topic today. We will discuss the importance of cycle of concentration and what is actually cycle of concentration means. So today we will discuss only the topic cycle of concentration, a detail for all, and you can ask me any question. So I need your help. I'm sure you are hearing me properly. You can see my presentation. So thank you Kibriya, thank you Asif, thank you Shadat, and thank you Nusrat. Can anyone write and confirm you can hear me clearly and you can see my screen properly? All is right. Just anyone can write and please confirm me, please. Please write everything is all right. Shariful Islam, thank you for connecting. Yes, Gulam Kibriya, thank you very much. So thank you confirming me, and Kibriya, I'm sure your family and everybody doing good. The things is all is okay, fantastic. So I like to inform you again, this is a very tough time we are passing, and we also are in very alert regarding the economic situation of global. Definitely it will impact our business, it will impact many things. So many job may be lost, and people are also scared. Business will be affected, means job will be affected. So we are already stuck at home. We don't know how long it will continue. Because for Bangladesh it is a very tough time. Now the rate is increasing, so that's not the message for you all. You have to be very strong and stronger, and you have to be design your time plan. You have to be plan your work at home very nicely, so better than office you can perform here in different way. You can plan for your office work, you can keep plan for your personal development, you can plan for your social work, you can keep communication with your parents, if you keep communication with your relatives. So there are a lot of social responsibility you can do right now, keeping yourself safe. So thank you very much. Asif Iqbal, you ask a question, how to calculate feed water temperature. How to calculate feed water temperature if condensate temperature 80 degrees centigrade and flash temperature is 110 degree centigrade. Thank you Asif, a very nice question. This is a energy related question. I think you can get it better by study. So today I would not like to discuss this energy related things. This is not a water chemistry, this is a water dynamics, but for that you need to do heat balance. You just need to do heat balance. I'm just showing you giving you the tips. You to calculate the mass of the condensate, how much volume or how much kg condensate you coming at, how much temperature, and it mixed with how much flash water. Then you can make from the thermodynamic table, you can may have this calculation what would the temperature. So thank you, welcome Mahabubul Alam, thank you others. So if you have any question related to water chemistry, then I like to handle, or I keep the topics today discussion as cycle of concentration. Thank you all. So if you have any more question, you can ask related to water chemistry. Okay, so today's topic is actually cycle of concentration. So I'm sure all of you know what is cycle of concentration. So as this class is public and many of maybe don't know what is a cycle of concentration. So cycle of concentration defined is a ratio. So it's a ratio between any concentrated water parameter to the diluted water parameter or the feed water parameter. It's applicable for any system where water become concentrated from the initial stage. Example, it can be applicable for cooling water system, it can be applicable for boiler water system, it can be applicable for RO, it can be applicable for evaporator and many system where water, inlet water or the water we fed, it concentrated in certain way. So this is a ratio of a parameter like TDS, can be conductivity, can be alkalinity, can be chloride, can be silica, can be iron. So many parameter we can use to calculate the ratio. All the ratio is called cycle of concentration. So if you want to see the formula is for TDS. If we want to calculate the cycle of concentration for TDS, so cycle of concentration for TDS for cooling tower will be cooling tower blow down water TDS divided by cooling tower makeup water TDS. So that ratio is cycle of concentration. If we consider for the boiler, so boiler water blow down conductivity divided by boiler water feed water conductivity. If we consider for RO concentrated TDS or conductivity or any parameter divided by RO fed TDS or conductivity. So I think you can understand what is COC. Alright, so please can you write what is the formula for COC? I am waiting for your reply. What is COC formula? What is divided by what? Thank you. Can anyone write what is COC so that I can go forward? I need your engagement much. So please write the formula. What is COC? Please write it. I am waiting for your write up. Mahbubul Alam, Kibriya, can you write what is the formula of COC that I already talked? What is COC mean? We understand. As you understand, what is COC? Kibriya, did you get it? I'm sure you get what is COC. Sharif, I'm sure you know it. Asif, obviously you know it. What is COC? So I like to share a video for you. Let's see how COC change in cooling water system and how COC actually happen. So if you see the video, we'll get a idea. The video is available in any YouTube. You can get it YouTube. How cycle of concentration increase. So this is the video. Just you can watch it and you can understand.
The cycles of concentration increase. We start by filling a cooling tower with fresh makeup water. Then we measure the level of elements in that water to determine its concentration, represented here by the two yellow dots in the tower. If the cooling tower evaporates 50% of the water, that pure water enters the atmosphere and is naturally recycled. However, the elements in the tower water remain behind in half the water volume. Fresh makeup water is added to the tower to replace the water that evaporated. This also adds 50% more elements to the tower water, increasing its concentration to 1.5 times that of the makeup water. The tower is now said to be at 1.5 cycles of concentration. If the tower evaporates half the water again, and fresh water is added to replenish the loss, the elements in the tower water will have increased another 50%. The tower now has twice the elements as the incoming water, which represents 2 cycles of concentration. As this process repeats, system cycles will continue to increase until they are controlled through bleed-off, or they reach the concentration limit of the cooling tower. Controlling cycles of concentration and the elements in water are extremely important to the operation of a cooling tower. When the elements in water concentrate to a level that exceeds the saturation point of the water, they fall out of the solution and form scale.
Thank you very much. So I think you understand how cycle of concentration increase in cooling tower, and we can have more understanding in a cycle of concentration. So far you have any question, you can ask me, you can raise what is cycle of concentration. I think any question, do you have any questions so far? How breakdown concentration divided by makeup water concentration, same ion. Yes, thank you Kibriya, you understand, thank you. The breakdown concentration divided by makeup water of same ion. Thank you very much, thank you. So what is the importance of cycle of concentration? Cycle of concentration helps us to understand the chemistry cycle up, right? Like if in cooling water the TDS of makeup water is 100 and it run by 4 cycles, so TDS of cooling water will be 400. So for any chemistry, 400 TDS can control, or 400 TDS can create scaling, or 400 TDS can create corrosion, or what happened we can understand. We can understand before start the dosing, before design the chemistry, or also we can understand the practical implementation, whether I am at right position or right chemistry I can maintain. So especially cycle of concentration for blowdown is very important to design its blowdown, design its makeup water, similarly design of the boiler efficiency, and it can increase, decrease the boiler energy consumption. Similarly for cooling tower we can design cycle of concentration, and based on that we can design how much blowdown I have to give, how much chemistry I have to maintain. So this is very important to understand the cycle of concentration. Thank you Renas for connecting me. Welcome in water chemistry class, and this is our 13th class, Renas. So if you have interest, you can keep like in our page water chemistry live, and you can watch the previous 12 video. Today we are discussing cycle of concentration of water. That is very important for any cooling water system, any boiler water system, or any RO system. So cycle of concentration gives us a lot of idea on scaling. Cycle of concentration also can help us to predict corrosion. Renas, thank you very much. So you go to our page later on after the class, and you enjoy it and watch the video of our 12 video. Then it was in English, so you can understand very easily. Renas, thank you. So cycle of concentration we need to measure for a cooling tower for different ion. Like we can measure cycle of concentration for TDS. So TDS of cooling water blowdown divided by TDS of makeup water. Similarly, we can measure COC for chloride, like TDS chloride of cooling water blowdown divided by chloride of cooling water makeup. We can also calculate silica, similar way, cooling water blowdown silica divided by cooling water makeup silica. So we can get COC for silica, we can get COC for chloride, we can get COC for hardness, we can get similar way, can get COC for calcium. Thank you Shamim bhai for joining, thank you. So we can also measure COC for different ions. So we have to see what are the concentration is aligned, means alike. Like if the concentration of TDS is, for example, 3, the all other parameter cycle of concentration should be near about 3. If unless the other chemistry impact on that parameter, like if I use acids or caustics in my cooling system, so it impact 2 parameter, like it increase conductivity or it increase or decrease alkalinity. If I use acid, it decrease alkalinity. So I should not consider COC regarding conductivity or alkalinity if I use acid in the system for any decision. What are the parameters that least impacted by other chemistry to design cycle of concentration or to take a decision depending on the cycle of concentration analysis? We need to choose a chemistry or ions that is less impacted by any other parameters. Like if I use acid, I can't take decision on the cycle of concentration of alkalinity or conductivity. So the parameter like conductivity is a very wide parameter. And Sajid Rahman, thank you for connecting. So conductivity will cover all the ions. So usually for considering cycle of concentration, we should not consider conductivity cycle. Like if I consider the cycle of concentration for conductivity for a cooling tower and decide how much blowdown I should give, I might mislead it. So I have to use a ion or a parameter that is less impacted by cycle of concentration, means the dosing I am giving. So usually the few ions that is commonly used like chloride, maybe less if I don't use hypochlorine or hydrochloric acid. I can use safely silica. Silica is the one of the important parameter, actually less chemistry can impact on it. So for design cycle of concentration or for considering cycle of concentration to make any next level decision, I can use the COC of silica as importantly. Some chemistry, some point I can use chloride also, like for boiler. Some cases I can use a particular ion like total hardness, I can use calcium hardness, I can use magnesium hardness. So these are the few parameters that it's important to consider cycle of concentration. Like for example, if I want to analyze the trend of the system, whether the system is under scaling tendency or in corrosion tendency. So if I want to understand the system tendency is in a corrosive zone or in a scaling zone, like if I understand the COC of a total hardness, COC of a calcium hardness and COC of magnesium hardness is differ a lot, then the system will be under scaling tendency. The COC of iron is vary a lot with other parameter, then it might give an example of corrosion tendency. So COC also can give us, help us to understand the water aggressiveness, whether this water can create a scale in the system, especially for cooling system, or whether the water can create a scaling in the system or corrosion in the system. So COC is very important. With the COC we actually design the blowdown. We do calculate, later classes we discuss how we calculate the blowdown, but just today remember it, which depending on the COC we calculate the blowdown. If blowdown increase, COC decrease. If COC increase, blowdown decrease. So COC is directly related to the water conservation. If we can increase cycle of concentration, we can reduce the water use, we can reduce the blowdown. So this is a good practice. But to increase COC, we have to do a lot of many other parameters to need to control. Maybe we have to control the pH, maybe we need to control the alkalinity, maybe we need to use the better chemical for the scale corrosion control. Maybe we have to use high dose for biocide to biofouling control. We need to higher dispersion dose to control the fouling. So to reduce the COC we have to do a lot of things, but COC measuring and monitoring is very, very important. Mahbub Alam, you asked me a question: cooling water, electric conductivity 1400 and sulfuric acid. After that increase 1600 and make of electric conductivity 650 microsiemens. So COC is 2.46. This COC is absolutely right or wrong? As I understand, if it is electric conductivity 1400 and the makeup water conductivity is 650, and if he use sulfuric acid continuously in the system, this COC, yes, the calculation of COC is 2.466, all right, but you should not consider this 2.46 COC to design any other thing or decide or compare the other COC to understand your system is in scaling or not. The calculation of COC, Mahbub Alam, is perfectly all right, but the question is if you want to compare the COC of this conductivity compared to the hardness and other ion to decide your system whether it is in a scaling trend or corrosion trend, might mislead you. So that's why if you use sulfuric acid in your system to control pH, you should not consider COC for conductivity COC. You can't consider conductivity COC for any decision. Rangaraj, welcome, thank you very much. Thank you, water chemistry class. We are here from Dhaka to help people, help my team to understand water chemistry. As we are in a lockdown situation, we are at home, so we like to improve our discussion group on many things. Thank you, Rangaraj. So today we are discussing cycle of concentration. So for boiler, cycle of concentration is very, very important. Like before designing the system, we have to design the cycle of concentration. Like for example, low pressure boiler, there is a simple limit for maybe TDS. Maybe TDS is like you can say for low pressure boiler maybe 3500, just for an example. So limit of TDS is 3500. So if I have the makeup water, the TDS is 100, so it gives an idea 3500 divided by 100, the COC I can maximum go 35. So this is how, depending on this 35 COC, I can design my makeup water requirement, I can design the blowdown requirement, I can design other things, so whether I can increase my COC or whether I can reduce my blowdown. So this kind of information is very important, calculation is very important, that helps if only we know the COC. Regarding for boiler, if we do calculate some COC and if we do the mass balance, like how much solid input in my system and how much solid or how much mineral go out or output in my system, so if the balance is not happening, that means I have to be careful, maybe system getting scaling or maybe system getting corrosion or maybe somewhere some deposition happening. So COC is very critically important part for any system. And right now I like to show you a video. You already saw first video how COC increase in a cooling system. So I will show another video for a cooling system, how it works, cooling system, and how the water concentrated. So let me show if I can show this video and if it is run properly. Let's see how a cooling tower cycle of concentration increase. So watch the video. Thank you.
Cooling towers are devices used to transfer heat or cool water for reuse. The basic operation is fairly simple. Hot water is pumped in from an outside source and sprayed into the tower. The hot water flows over what is called the fill. This spreads the water over a larger surface to allow for more cooling. Cool air flows over the fill, which transfers more heat through evaporation. The heat exits the tower, and the now cooler water gathers in the basin. This cooler water is then pumped back into the system to be used again. Cooling towers are just one part of a cooling system. In this lesson, we will cover the basic process of how a cooling tower works, define the components, and describe their purposes. And we'll also cover some common terminology that is used when discussing cooling towers. Within a cooling tower, you will see the use of plastic or wooden slats. These are called fill and are used to direct the flow. The purpose of this is to increase the area of contact between the hot water and the cooler air. There are two types of heat loss that occur in this process: sensible heat loss and evaporation. Sensible heat is what can be felt or measured. Evaporation accounts for the majority of the heat transfer and is the most critical aspect of the entire process. Many factors can affect the efficiency of the evaporation in a cooling tower. Things such as relative humidity, outside temperature, and wind velocity can affect the efficiency. Even the design of the tower, water contamination, and outside equipment will also play a part. Cooling towers are classified by how airflow is produced. This allows them to be broken.
So this is how a cooling tower works. This is a simple basic, and I would like to show another video that will help you to understand how cycle of concentration increase in a cooling system.
Repeating the loop. For cooled water from the basin,
you will get all the video in the internet, so you can download it and you can use it for further for understanding better. Or if you have any question, you can write and comment also.
Fresh makeup water is added. Evaporated water leaves behind dissolved impurities from the makeup water, which concentrate and cause scale, deposits, and corrosion. Concentrated impurities in the tower are removed through blowing down tower water to the drain. The basin water level drops due to these evaporation and blowdown losses, and more makeup water is added to maintain level. Open recirculating cooling towers save tremendous amounts of energy and reduce greenhouse gas emissions compared to air-cooled systems. Challenges include water conservation, corrosion, scale, deposits, microbiological activity. Professional water treatment minimizes these challenges.
So you understand how a cooling system works, and now if you have any question regarding cycle of concentration, you can write and comment. So Mahbub, thank you very much. Your question, you're right. When you dose acid in your cooling system, it will impact it on conductivity, it will impact on pH, it will impact on your alkalinity. So these three parameters normally impacted. So as conductivity impacted by acid, so for calculation to decide any decision comparison cycle of concentration. So if you want to compare cycle of concentration of hardness with cycle of concentration of conductivity, so you should not compare if you use acid in the system, because acid impacted on the conductivity as well as the alkalinity. So comparison only, you have to compare the parameter that is not any external impact, like it can be silica, it can be total hardness, it can be calcium hardness. So usually people use calcium hardness, total hardness, magnesium hardness, silica. For boiler, people use chloride is very importantly. Sometimes for silica also in boiler can be used for considering the cycle of concentration, because if we compare with the wrong cycle of concentration, we might conclude a wrong decision, because depending if any system cycle of concentration comparison give me the idea that system is in corrosion or system is in scaling trend, so I will take some action. So if I have the misinformation or COC I compared and I take action based on that comparison, then I might lose money or I might lose water. So that's why we have to be very careful on cycle of concentration. And if we want to understand more on the cycle of concentration impact, the things that is impacted, number one, if we can maintain good cycle of concentration or proper cycle of concentration, we must lose scaling control, we must lose corrosion control, we must lose high blowdown or low blowdown. So this is why cycle of concentration is very, very important. And for any system, before even design the total water chemistry, before design the product for use, before design how much makeup water we need, before design how much blowdown we have to give, how much energy we might lose, so all these things before we have to design the cycle of concentration, and based on the cycle of concentration we can design makeup water requirement, and we can design the pre-treatment as per cooling system or as per boiler system. So cycle of concentration is a very important design parameter. Before installing our event boiler or before installing our cooling tower total setup, we have to consider cycle of concentration, and to take this pre-action of cycle of concentration, we need the machine manufacturer guideline, limit of the water chemistry for cooling system, for boiler system or for RO system. What are the limit I can tolerate? Based on the limit, what is the makeup water available to me? So we have to calculate the cycle of concentration accordingly. For example, I have on 11, so it's a very last minute. For example, if I have a limit for a TDS for a cooling system maybe 1000, if my makeup water is 200, so that indicate that COC maximum 5 I can design for the plant. So in this way you can calculate all other COC also, or other parameters COC, then you can design your system, then you can design your pre-treatment, or you can understand how much makeup water you need. Accordingly you can design your pre-treatment system. So thank you very much for giving me. My time is 11, up to 11 I will discuss on this. So if you have any question, Masudul Alam, you join at the end. Thank you for joining. The video is recorded. If you want to understand, please you can see the recorded video. And I'd like to request you all, please share on your wall, share on your team, share on your group, and like the page Live Water Chemistry Live, so you can watch all the video. That there are 13 video including today, so you can watch one by one and you can learn. If you have any question, you can pass it to me. I will try to comment you. So thank you very much and good night and Assalamu alaikum. That's all for today. Thank you.